going to Las Vegas, going to travel the world and potentially meet these very high technology experts like maybe Elon Musk himself or Steve Davis.
So it's two components that get injected inside. They mix, they get hardened, and then in the end we have a very hard tunnel wall that is then pushed back to the outside, or respectively, the machine is pushed to the inside then.
What particularly you want to improve for in the next competition? And also, where do you think Swissloop Tunneling will be in the next 10 years? Hello everyone, welcome back to Wevolver's UTEP interview series. Today we have Eugenio and Luca from the Swissloop Tunneling team, which is a student-led team from ETH Zurich that won last year's Design and Innovation Award and second place at Not a Boring competition in Las Vegas. So Eugenio, Luca, can you tell us a little bit about each of yourselves and your role in the team? And also, how did you join the Swissloop Tunneling team?
Yes, we're glad to do that. So my name is Eugenio Valli. I am a Swiss engineering student. I'm finishing my master degree in mechanical engineering at the ETH Zurich. And I got to know Swissloop Tunneling quite randomly, actually. I was at a lecture and I heard about the SpaceX Hyperloop competition that happened a few years ago by Elon Musk SpaceX. And I met another engineering student that proposed me to join the team for this new competition that Elon Musk and Steve Davis from the Boring Company announced in, I'd say, August 2020. They're not a boring competition. So I decided to give it a shot and I entered the team in October 2020 as a mechanical engineer for hydraulics at first. And after 1.5 years, I'm still in the team because I really enjoyed the project and I found it really, really interesting and a very nice opportunity. So maybe give the words to Luca now to answer.
Sure, thanks. So my name is Luca. I've joined around the similar time as Eugenio in November 2020, so shortly after the founding of the organization. At that point, I was quite at the beginning of my studies of mechanical engineering. At the moment, I'm in the last semester of mechanical engineering, so almost done with the bachelor's. And the way I joined was also quite spontaneously. So I saw some recordings of some lectures because I was, as usual, quite behind with the lectures. So I saw the recordings. And there was a person coming in introducing the project. And since I had always wanted to join one of these engineering projects, I also tried to give it a shot. I wrote an email and was like, hey, I hope I'm not too late, because the recording was delayed, obviously. I hope I'm not too late. Can I still join? And then shortly after was accepted and joined for the soil removal mechanism as a normal mechanical engineer. So I was appointed for designing the gearbox for the kind of cutter head in the front. And then now at the moment I'm head of mechanical engineering, so I'm overseeing all of the machine. So generally, for those that don't know, we built a tunnel boring machine, which obviously has a bunch of different subsystems fulfilling different functions, and each of these subsystems have a small team appointed to it. And my job is kind of to oversee all of these subsystems, see that they work quite well together, see that they are quite well integrated. There are no issues coming up, and that's my job at the moment. I'm very glad that I've joined this project because that was kind of one of the main reasons why I joined ETH in Zurich, because originally I'm from Austria, so it was quite a commitment to change country, basically. And joining one of these projects was one of the motivations to do that. And I'm quite happy with how it turned out.
Yep. That's very exciting that both of you are like, I can even say it's quite an accident that you both are in the team. Like it's a there's a funny story behind it, and then I'm glad that you guys are glad that you're part of the team and the team is achieving great things now. And I'm particularly excited when Luca mentioned about different subsystems that we have in the tunneling robot, right? And then we're definitely gonna talk about that later on. But before that, we wanna step back a little bit. Like maybe we can give context to some of our viewers about like what is actually Hyperloop? What's the bigger picture of it, and what problem is it trying to solve? Maybe
Mhm.
someone can explain a little bit about that.
Yeah, so the Hyperloop concept was born with Elon Musk a few years ago when he published the white paper Hyperloop Alpha, and the whole concept is concerned about high speed transportation means. So the idea was to reduce traffic, to reduce travel times. New transportations mean new transportation technology needs to be developed, and for this, the Hyperloop concept is concentrated or is focused on creating this vacuum tubes, but vacuum transportation channels where high-speed pods or capsules or trains could travel from one city to another, covering very long distances in very reduced times. And the Hyperloop concept is based on this again vacuum tubes, so where these pods or capsule could travel using electromagnetic levitations, air levitations, or different kind of technologies. And this is where all of this started, I would say 5 or 6 years ago. The Hyperloop SpaceX competition was focused on having student teams or non-profit organizations creating these smaller versions of the spots and try to beat the speed limits imposed by tubes or tubes technology. And after a while, and where we come into play is because, of course, we can't always put tubes above the earth. Sometimes, especially in Switzerland, there's lots of mountains, lots of obstacles that you need to avoid. And so the underground infrastructures and facilities also need to be developed alongside or in parallel. So when we heard of the Nottingham competition, we were pretty excited about it because we said, hey, this is probably the next important step or necessary step for the Hyperloop concept or the Hyperloop technology to be fully developed. And that's why we are focusing on tunnel boring machines to cut tunnels and to dig tunnels of, for now, just smaller dimensions as a prototype or a proof of concept, but later on in the vision to also try to contribute to get help towards the development of the Hyperloop concepts worldwide.
Yep, yep. That's interesting. So to my understanding, like there's this two big aspects of making the Hyperloop like a reality, right? There's the teams making the pods, and then there's the team making the tunnel infrastructure so that the pod can go inside the tunnel,
Hmm.
right? And
That is
then what
correct.
your team is doing, what your team is focusing is on the tunnel robot, the robot that makes the tunnels, right?
That is
And
correct.
so uh, and why is it so important to have this new innovation in tunneling robots or machines? Like, what's and how is it different to conventional tunneling mechanisms? Like, what's different about it, and why innovation here is very, very, very important in making a hyperloop a reality?
So usually in tunneling at the moment, the issue is that it's quite slow. Kind of, it's a slow process. It's very tedious and therefore very expensive in the long run, which is why kind of the feasibility of Hyperloop at the moment is very limited, since digging those tunnels is super expensive. So a way to kind of make it more feasible or even possible is to increase the speed of how you of how you kind of dig those tunnels. And in order to achieve a higher speed, there's a bunch of things that are necessary in order to increase it. That is the kind of removal of the people that operate the machine. So each person that operates it obviously is not perfect. They might make mistakes. It's dangerous for them to operate the machine. Um, there might be injuries. They cannot work 24/7, obviously, and so on. So the first aspect is getting rid of people. The second aspect is at the moment digging those tunnels is not continuous. So when a tunnel is dug, kind of segments are transported inside tunnel segments, which can reinforce the wall in order for it not to cave in, which is kind of the second aspect. And commonly it's referred to as the holy grail of tunneling, making it fully continuous, so no stops along the way. And the bottleneck at the moment for that to be achievable is the lining, so the structure of the tunnel itself. It's not necessarily the cutter head at the moment. You might believe that it gets destroyed very quickly. That is not the bottleneck at the moment. It's just the lining. So that's actually where we come in. So we are aiming for this continuous process of creating this tunnel. And since we are only a student project, and we have no extensive funding by any entity, we scale down this tunnel boring machine also to fulfill the requirements of the competition, which was 0.5 meter in diameter, which counts as micro tunneling. Obviously, you cannot drive a Hyperloop pod through 0.5 diameter tube. That is not possible. However, in the future, we are aiming to scale that up to make it feasible for transportation applications. However, at the moment, it's just a prototype and kind of a feasibility study for it to be continuous, not operated by people, but automatically. So we give a predetermined path where the robot should go, and with sensors and actuators and all the control systems, we are fully optimizing the thing where no operator is necessary anymore. And that is kind of the goal. That is kind of the goal for this tunnel boring robot. That's actually where the robot aspect comes in. And that's our innovation in that respect.
That's very interesting. And speaking of the tunnel creation, like it's basically like a 3D printing technology, right? So what's interesting about your tunnel is the robot can 3D print the tunnel while continuously moving forward. And I'm sure like a lot of the Wevolver viewers here are familiar with 3D printing technologies, but the conventional ones and I'm pretty sure it's very different than yours. Like we know, I happen to have one over here where we have the filament and there's the extruder and it prints to the heat bed. Like, and maybe you can tell us a little bit about how does yours work, like the 3D printing aspect of building the tunnel, the robot.
Mm-hmm. Yeah. So we've kind of had some change in that aspect lately. So the machine or kind of the mechanism that we had until kind of 1 or 2 weeks ago was based on a 2-component polymer glue, where we inject 2 components or 2 highly viscous fluids inside the machine from the outside. So we pump it in, and then the inside they merge and then form a very hard plastic when they combine. So it's a chemical reaction. Then in the end, it's actually a duromer that gets created, and this also then merges with 2 foils that we unroll from the mechanism. So in the end, we have a sandwich structure of a tunnel structure, which gets then extruded to the back. So it's 2 components that get injected inside. They mix, they get hardened, and then in the end, we have a very hard tunnel wall that is then pushed back to the outside, or respectively, the machine is pushed to the inside. Then the tunnel wall actually stands still. And then kind of this new innovation that we're trying to achieve in that area. So already this mechanism was deemed to be very innovative. I think we'll touch on it later, but for this system, we've actually received this innovation award. But in our mind, it is too complex. It is too unreliable, which is why we have replaced it with a different mechanism that we have started to engineer, which is based very similarly to a FDM printer that you have standing behind you, based on a thermoplast. That
sorry to interrupt. Does that research is what got you the innovation and design award? Or is that something else? I'm sorry to interrupt.
Yes, exactly. So this mechanism that I described, where the 2 polymers kind of mix and then get hardened to form the tunnel wall, this actually got us the award. Kind of this system received this innovation award.
Very cool. Yeah, you can go on.
And then now kind of a new mechanism that we're planning and designing is actually more similar to a 3D printer. So we transport this thermoplast granulate, so PLA, PET, similar to a 3D printer. We transport it to the inside with air pressure, and then in the inside we melt it. So it gets melted with an extrusion screw. and then it gets kind of melted and combines with the granulates combine with each other, and then they form kind of a tunnel wall which gets extruded to the back. So this is much simpler than what we had designed last year, and we're trying to make it then more kind of faster, more reliable than the previous one. And with this one, we are also aiming to then compete at the next competition, combined with the rest of the tunnel boring machine, of course. So that's just one system of 6, 7.
Yeah, that's very interesting. Can you tell us like a number for like you mentioned like you want to do it faster or like faster like how fast does it go, or you have like a number for that?
So the previous one was designed to reach 0.4 centimeters a second, so that's 4 millimeters per second. This is just a constraint because of the time it takes for the polymer to react, so that's 8 minutes. And if you take those 8 minutes of reaction time and take the length of the kind of part of the machine where it actually has time to harden, then you arrive at the 0.4 centimeters a second. And this new system is designed from ground up to reach 1 centimeter a second. So there you can imagine that big aspect that we have to take into account is the heat management. So everything in that respect is designed for 1 centimeter a second. And since this is the bottleneck, actually this system is the speed bottleneck, the rest of the machine will follow that speed.
And just by talking this one subsystem, I can already imagine like how complex it is to design such system. And I imagine the process of designing, constructing, testing, prototyping must be very intensive. And and of course it will take a lot of time, right? So what's the most challenging part of the process for each of you, and how do you cope with this intense workload, I imagine? How do you manage your time, or like how challenging is it? Or maybe you have a story about it.
Would you like to know it personally for us, or also in the respect of the team, the whole team?
To you, and then you can talk about the team as well.
Okay. So Jenny, maybe I can start. If you want to, you can also elaborate on other aspects later. For me personally, what always drives me is kind of the why, kind of why we do it. And the reason why obviously is to make an impact on the very, very large aspect of what humans do, which is transport. And always keeping in mind why you spend the time on it really drives me. It motivates me to put in more time. And then it also starts to feel not like a burden anymore, but to feel very inspiring. And there have been times where we spent weeks on end in the workshop, and sometimes slept on some chair in the workshop because we had to finish setting up a system for an event on the next day and so on. But none of it felt like I wanted it to end or something. So that's personally what drives me. And also kind of to interpolate that to the rest of the team, I think when you have a supervisor, have some person that you that gives you tasks or that kind of plans the way of the project, and that person is super inspired and driven and tries to make everything work in the end, you are also feeling more safe. You feel like, oh, I have to perform, so I have to also spend the time with the project, also put in the hours to kind of contribute to this larger cause of why we actually are existing. And then there's kind of the second factor, the rewards that we get from it. So last year we've had 90 industry partners. We have been in contact with hundreds of people to make everything work. And each contact is kind of something special to everyone. So it is very inspiring to come out of, or kind of to still be in university, and also on the second hand have this immensely broad kind of network in industry. That's something that most students don't have. So they come out of university and have basically no one in the industry that they know, no opportunity to have a job priority or something. That is something that we really why we're different. Kind of, some people have gotten jobs from companies that sponsored us.
Yep.
There's a person that now works for Implenia. There's a person that works for a hydraulics company now. There are people that are actually going to join the boring company. So that's very inspiring for all of us to do that.
Yeah.
Yeah.
That's very cool.
For me,
Eugenia, you
yeah,
have something to add?
yes, so for me as well, I think what Luca mentioned is also like the main motivation why I'm here. I started because I've always followed like university courses, so I got to know a lot of theoretical concept, theoretical knowledge, a lot of exercises and different topics, but I've never really put hands on a system, put hands on a practical project that really could have helped me put the theoretical knowledge acquired into practice. So the first, like the kick off for me was really put this into practice and start doing something out of what I've learned at uni. Then again, as time went by, I really started to learn how awesome it is to, as Lucas mentioned, get to know industry partners, industry experts, and interact with them. So learn what their actual problems are, because of course the theoretical knowledge is one thing, but when you put it into practice, there's loads of other factors that we never encountered in classrooms. So for me, this hands-on experience really is one of the main objectives. The rewards, of course, going to Las Vegas, going to travel the world and potentially meet these very high technology experts like maybe Elon Musk himself or Steve Davis or engineers from the Warren company is also really rewarding. And then, of course, as a team experience, like sharing this passion and this, as Luca mentioned, like pulling all-nighters at the workshop or the testing side, because everyone wants to do that. Everyone wants to be there and give their contribution to make it look good and make it functional. So this is very important. And then of course, like the bigger dome is the impact that we could potentially do. Of course, now we're a student team, so we're working on prototypes or smaller versions for the proof of concept. But ideally, what we would like to do also, and we could talk about this even later for the vision, is to extend what we're doing to like real world application, real industry problems, and try to make an impact and change how transportation works for humanity and worldwide.
Yep. And you slightly touched about how inspiring it is while you were there in Las Vegas, right? And then with the other teams and as well, like um so over there you get to see the other teams robot basically, right? Um and also what is it like what was it like looking at other teams? Do you guys like talk to each other about like how you're basically solving the same problem with a completely different kind of engineering and different way and what was the experience like? I imagine it must be interesting.
So, Virginia, should I or?
Please.
Okay, so even though it was a competition, you can imagine a competition being very
Yeah.
fierce and aggressive or whatever. It wasn't at all like that in Las Vegas. So it was already a huge achievement to get there, kind of combined with the COVID
Yeah.
travel restrictions to the very hard um, kind of guidelines that we had to, or kind of requirements that we had to fulfill to actually pass those tests that they gave us, that the Boring company gave us. We had already achieved so much, so kind of the environment was quite friendly with the other teams, particularly with teams from Europe as well. So TU Munich, teams from England. We had a very good time with them. We exchanged tools, we exchanged ideas, we took a look at our machines, gave obviously compliments and comments on their technical solution. So it was a very amazing environment, actually, very inspiring. And many of those contacts actually stayed. So one person actually joined our team from another team because he found that we were more inspiring than their team. I'm not going to mention the team, but that was actually also very funny. And then additionally to that, us and three other teams, we founded a different organization to that's the European Tunneling Week, where we're actually also aiming to in the future organize European tunneling events. So after all, it was not at all aggressive or anything. It was super chill and great environment. And regarding the technical solution, some were in the similar direction as us. However, many didn't pass the safety checks because they were kind of incomplete systems. Because obviously the time was a big constraint for many, as was the budget.
Yep.
So many couldn't finish their system properly, which is why they didn't pass the safety tests. However, there were other solutions as well that were kind of interesting for us to see. In our minds, a bit less innovative, however, then more reliable, of course. And it was, after all, very inspiring to see different solutions and discuss about it and so on.
Yep, it's very inspiring to see like the spirit of the competition is not really like it's very positive basically. Like you're helping each other because you're trying to basically achieve the same goals, right? Your competitor are basically the same people as you. Like they just want to achieve the same goals. Just give me a little flashback. Like I also joined some robotic competitions when I was in high school. But that's a different story. So, and one thing I also love about you guys is that you mentioned that you guys are motivated because this project is bigger than you guys. There's a future where this can impact a lot of people's life. And speaking of the future, yeah, I want to talk a little bit about like what particularly you want to improve. I think you touched on that a little bit, but maybe you can explain further. Like for this year's competition, yeah, I mean the next competition, and also where do you think Swissloop tunneling will be in the next 10
Mm-hmm.
years? Yeah, maybe
Yeah,
you can answer that.
totally. Yeah. So I think you said it very correctly. This project is much bigger than ourselves because tunneling, as first of all, is a technology that has been going on for quite some time now. And also this Hyperloop concept is something that is being developed and carried out in parallel by many different countries and institutions and groups around the world. So yeah, for us, it all started because of a competition. So we wanted to kick off a project because we had this opportunity with Not a Boring competition in Las Vegas, and we said, okay, let's start doing this. Let's start putting engineers' brains together, build this tunnel boring machine prototype, and compete there. So this was the focus last year, and it's kind of is still focus for this year. So we're going to be in Austin, Texas in January for the second version of the Not a Boring competition. And yes, our team is currently trying to optimize and renew and update the tunnel boring machine that we developed to compete and potentially win there this year. However, what we will also like to do is try to, as I mentioned earlier, develop the project also for more industry relevant applications. So not just to compete against other students or non-profit organizations with under these sorts of fixed boundary conditions like the fastest tunnel boring machine and most accurate, but also like try to tackle real world problems. Like we are in contact with different industry partners, as Luca mentioned earlier, which proposed or brought to light problems that our machines or our systems could potentially help solving. So what we would also like to do is start to focus on maybe more on the subsystems itself to work closely with these industry partners for their problems. Our team is a student association, so this is also one thing, as Luca mentioned, we are freelance for now. Everyone does it on their free time, except for a few exceptions, which are doing it for like a master thesis or semester project. So the time and the infrastructure and the logistics is also quite limited. That's why we would like in the future to also have this kind of organization, this structure, allowing people to do it like maybe for an internship or for again a semester, master or bachelor's thesis, or we're also kicking off some other projects together with academia. Another problem with this kind of project is that, again, the infrastructure and the capital are quite intensive. So we're building a prototype which is half a meter in diameter, roughly. It weighs 2.5 tons and it's 7 meter long. So already with these small dimensions, we struggle a lot to find the space, to find the lifting systems like cranes, forklifts, and so on. So the idea, of course, is to scale up, but we now realize for a student project, we need to focus on this dimension for now, because of course, if we wanted to build now 4 meter
Yep.
diameter tunnel boring machine, we would need much higher, more extensive infrastructure. So for this year, again, focus is Not a Boring Competition 2023 in Texas, kicking off projects together with industry partners, focusing more on subsystems, and in order to develop different projects in parallel, which can be applied to industry problems. And a longer term vision is, of course, we always have Hyperloop in the back of our minds. And in order to get there, we would like to start learning. You also need to consider that we were founded in September 2020, so we are a relatively young association, relatively young team. So we're still learning a lot on the process. And and yeah, so these are other key points. Concerning maybe the longer term vision, we have many interesting talks, many interesting meetings internally and also industry partners trying to figure out, okay, what can we actually do? What is feasible for us to do? And of course, the Student Association, as I mentioned earlier, is going to focus on those topics. But there are some other ideas like a spin-off or a startup, or maybe going more into company structure. So funding maybe a spin-off of Swissloop Tunneling that would be really focusing on gathering big amounts of capital, big amount of infrastructure and partners to start doing it industrially or for a commercial purpose. Exactly. So these are kind of the points. To me, and I think Luca too, because we talked about this a lot, Swissloop Tunneling is always going to be there for these student associations, for students like ourselves to top off their knowledge, top off their curriculum with this hands-on experience, which we think is super valuable because it tops off everything that is being learned at uni. And so it is always going to be there. And in parallel, of course, as I mentioned, these industry or commercial applications could also be kicked off. So we always have this exchange between students that learn something, and as soon as they get enough experience, they could get drafted for a company, for a real industry, which is going to scale up the systems slowly and try to test out what works, and also closely collaborate with other associations. To mention one, we have a sister association which is called Swissloop, which participated in the SpaceX Hyperloop competition in 2018, if I'm not mistaken, for the last time. And they're focusing on the pods, these capsules that are traveling through the pod, through the vacuum tubes. So longer term vision is to close this gap and start collaborating with them again to develop real world applications, maybe create some bigger tunnel boring machine, bigger tunnels, and create the infrastructures for tests for transport of goods or people for the Hyperloop concept in the future. So this is the shorter to longer term vision of the project. And it's really interesting because again, we learned so much this year, and we learned how difficult it is to dig tunnels. Maybe compared to Swissloop, which are building the pods, just to give a comparison, our machine, as I mentioned earlier, is 7.1 meter long and 2.5 ton heavy, whereas the Swissloop pod is much, much shorter, about 1.5, 2 meters, and a couple of 100 kilograms heavy. So the infrastructure and logistics is on a different level. And of course, we also need to consider these things when we talk to industry partners and sponsors and consider what we can feasibly do.
Yep, and that's very interesting actually. Like, and then my last question actually. I know it's very hard to predict the future, especially at this current stage, right? You guys are making prototypes, and I know like there are a lot of variables coming in, not only the engineering factor, but also like, let's say, safety, like regulations, and like other things like that, logistics, like you mentioned. And but maybe can you give us like a really rough estimate on how soon do you think people are gonna start, like how soon can people start using the Hyperloop tunnels and the pods in the future, and it's being used in by the masses? I know it's very
Yeah.
hard to predict, but can you give us like a rough estimate? I know people are like, people really
Yeah.
want to know
So yeah,
this.
as engineers, we always like to talk conservatively, not try to give too like enthusiastic,
Yep.
optimistic values. But I think nowadays for the Hyperloop concept, for the pods, the capsules, there's many industries around the world that are currently developing it. And I've already seen, like for instance, for the Virgin Hyperloop industry, they already started doing tests with full-scale prototypes. So from if I read correctly, they are aiming to start kicking off or developing industry-ready products around 2026, 2027. But of course, it strongly depends on many different factors. There's of course the technology itself, which is very difficult, very complex, but there's also policies, because as soon as you put infrastructure above and underground, you need to talk to the government, you need to see the regulations and how it works. So it really depends. For me, I would say for the Hyperloop part, or at least for the underground part of the Hyperloop concept, I would really be happy if I could see it by the end of the decade, so around 2030. Whereas for what concerns underground technology, since what Luca mentioned earlier, tunneling is really a slow and expensive process, it could really take a bit longer until like faster and most efficient tunneling applications could be ready to dig Hyperloop tunnels under cities or between cities like London and Berlin, London and Paris, Zurich and Paris. So for me, if I have to give a rough estimate, I would say around the end of the decade for above ground infrastructure. And I would be really happy to see it working for around 2040 for underground infrastructure, where we could really rely on Hyperloop to travel from one place to another. I guess we will have to see about that, and
Yep.
we'll do our best to make
Yeah.
that.
We'll see
Yeah,
about
make our
that.
best to make that happen
Yep.
as early so early.
Yep. And Luca, do you want to add something onto to that?
Um, no, I think Eugenio said it all. I think he's
Yeah.
he's the visionary of the team. He plans it all out, and I think I think in engineering teams, something that I wanted to mention earlier as well, when you asked about the biggest difficulties actually of the team, it's often not the engineering solutions that are lacking, but very often factors that include, in our case, people, kind of how to keep people motivated, how to have people pull it on the same string, and so on. If that is ensured, I think everything is possible, because motivation kind of can reach everything if it's there. And yeah, I would hope if the timeline that Eugenio suggested comes to fruition, and we can actually travel in Hyperloop pods from Austria to Zurich to visit my family for lunch and come back to see the next lecture. That would be great.
Yep. Motivation can reach everything. Very well said, Luca. And thank you, Eugenio and Luca, for your time with us. And good luck for you guys and for the team for the next competition. And
Thank you very
thank
much
you
for
very
having
much.
us.